junk, keeps the good stuff, and comes out with a picture. It's going to be the same with the drones, the drone mapping, and so on. So, anyway, yesterday we had a presentation. I was going to have him here today, but he chose yesterday rather than today. He's somebody who's been into drones for 4 or 5 years, after building them for 2 or 3. So we found out very quickly when we got into drones that they crash. And when they crash, they break. So you've got to learn how to fix them. There's just no way around it, especially if you're a beginner. So we're going to go over today some of the things you can actually build your own kit. And that's what our goal is, to start building some, which I'll show you here, so that we know how to fix them. If you tear it apart, start from scratch, you'll know how to put a motor in easier than if you just try to shove a motor into a place. So anyway, here's the kit. And all the parts are here. Just buy it, everything's there, and then you put it together. So here's another kit. And there's your frame and all the parts, which we'll go over in just a minute. So let's go over the parts of the called quadcopter. Anybody know why we're called quad? Right. Let me get rid of this here and go a little bit over frames. He showed us yesterday 2 frames. One is like this. Okay. Here's the motor, the propeller, like that. Okay. And there's another one like this. Okay. Now this is quad, 4. But you could have something like this. And now you got 6 motors. This is a little bit better than 4. 4 is better than 2. 2 is better than 1. Fly an airplane, generally speaking, you hopefully have two engines. If one goes out, you want a spare somewhere right at the minimum. And then if the airplanes need more and more, they'll have four engines and so on. So, but anyway, there are multi-copters or multi that have more than 4. But this is kind of the standard. And then you have different kind of frames. So here's a frame. So you start with the frame. Okay. And then in the frame, you have a top and a bottom. Okay. This is the Earth, let's say. So this is your copter, your frame. This is the bottom. This is the top. And in the lingo of the industry, they call this a dirty frame and a clean frame. So one easier way to remember it, if it comes down, it's going to get dirty. That's not why they call it dirty, but anyway, dirty frame. So you have a top and a bottom, but you've got to get all that stuff squeezed in the middle. So, and you can have little things here called standoffs to hold it apart and so on. Then you've got to start packing stuff in here. So the first thing you need is the brains. Okay? It's not going to do fly without brains, and that's called the flight controller. Flight controller. So in this comes a flight controller. Okay. That's the brains that tells those 4 propellers how fast to spin, when to stop, when to start, how fast to go, and so on. So you need to have a flight controller. Next important thing, Jim, is what? Battery. So now you have these little batteries. And these are LiPo batteries. you should know that they are very, very dangerous. Okay? We talked about that in the past, so I don't want to go over all that now. But handle them with care. Watch them with care. Okay? Most of them will come rated as to the voltage and the milliamps. So the voltage is what's going to drive it. So how much voltage do you need for this whole system? The milliamps is like the gas in the tank. How much gasoline do you have? So what is it going to be able to do once you add all these things to it? And how far is it going to be able to fly? 1 mile, 2 miles, whatever. So first of all, back here, you got motors. Okay, 1, 2, 3, 4. Now the motors are brush motors and brushless. Brush motors. Brush motors are the cheaper ones, et cetera, The brushless are the better ones. They're easier to control and they're more expensive. So it depends on who you buy it from and what kind of drone you're going to buy, and so on. So
what's the difference? Physically, what is the difference? I know what a brush motor is.
Okay. You know what a brush motor is? Good. Okay. Brushless is what?
Without brushes.
No brushes.
How can it work?
I was trying to think how to say it. Your magnets are set up different. No brushes. You have magnets here, here, here. Okay. Then you have your rotor here, and as it goes around,
the magnet power moves.
Yeah, as it goes around.
It's an electronic magnet.
Right. It turns that shaft.
Okay.
So, but it doesn't have the brush.
Okay.
Okay.
Then it has to have a computer to run it.
Pardon?
Brushless motor, they have to have some computer to figure the magnets.
Yeah, that's what the flight controller is. That flight controller is a little computer.
Yeah.
It's got lots of brains in there.
Oh, okay.
They're doing that with that, one of the rails. I don't know if it's still a train, it's still experimental or not, but that's the same thing. The magnets turn on and off and they draw the train along. It rides on air.
Then something unique to this, as you get into the better motors, is electronic speed control. So here you have your motor, and here you have the ESCs. The ESC is like the foreman. It's telling that motor what to do. The flight controller tells ESC what to do, then the ESC tells it what to do. Like you might want these two motors here at 50% and these two at 100%. So your electronic speed control gets the signal or brain power or whatever from the flight controller to tell the motors what to do. And that's how you control the up and the down, the right, the left, and so on.
They don't control it by voltage.
Pardon?
They don't control it by voltage.
I can't hear that far away.
I said they don't control it by voltage, like the older motors, you control the speed
No,
by
no.
voltage.
These are controlled by, here's the kit.
Volt control.
Here's a kit of just a flight controller.
Yeah, that does that too.
And that's to say, the brains of it. That does all these calculations. The GPS, what you've been talking about, takes all this stuff, and it tells you, you're here. That guy wants you to stay here. Don't you move.
Yeah.
So it's getting that down, the GPS signal down, and it's not going to move until you say move. So, okay. So we got most things covered here. Now, the next thing that people want to do for whatever reason, for photography or everything, they want cameras off here. And we went over this in the past a little bit. First person vision, FPV. the camera is gonna be there to shoot pictures, okay? However, it can be there to drive it too. In other words, if you're gonna do drone racing, basically there's almost two categories of drones. Those for photography, for all the reasons we want photography, or eyes if you want to call it that. And those for racing. If you're racing and you're gonna go through hoops around, you've got to be able to see those. Okay? So the camera, you may have a camera on the drone, where my drone, you may have a camera here, let's say we're here again. A camera here to see, like a pilot sees in the cockpit, but you might have another camera here to take pictures, or to do your drone mapping, whatever you want to do with the data. This one is more for flight control. Okay? So, now, the problem is these drones can go a long ways. And with the FAA regulations, they say the drone has to be, you have to see it. So it has to be in your line of vision. So there's a whole set of laws that coming to be. One, it can't go any higher than 400 feet, okay? You have to be able to see it, what they call line of sight. So you can't have it run around the building, behind the building. You've got to see it. So line of sight, more or less like a radio wave. It's only going to go here. If you can't see it, you're not supposed to be flying. So now you got a problem because you're going to do this all with radio control, RC. And that's been around many years. I don't know how many, back to 1930s, probably 39, I think, it started radio control. So now, if you look at the sheets there, maybe sheets on the electromagnetic spectrum. Everybody should know that for sure, all students and so on. So you look down here, here's kind of the middle of it. And this is what we call the light part. This is what our eyes can see. But this is all energy. So what I like to do as far as when we're teaching and try to blend things together, this is 10, okay, 10 to the 6th power, okay. Oh, we got that right. 6th power, so 1,000,000, okay. So we want to go way down to that many decimal places, up and below. And you use with math what is called floating point integers, where your dot can be anywhere that you want. It can float back and forth. Like for your GPS last week, we showed where you might have 4 or 5 numbers on this side of the integer down below. Okay? So anyway, here we got X-ray, which we all know about, and so on, and then ultraviolet and infrared. So most of us have heard of those. We use infrared in the house. I have a security camera. So when it gets dark, the security camera still sends me a signal, and you can still see a picture, but it's using infrared. It's above what my eyes can see. My eyes only see dark. So ultraviolet can be used to sterilize things and so on. So as you go up here, then you get into what we know as FM. First came AM, then FM, and that's amplitude. AM is amplitude modulation. It's where the amplitude up here on a sine wave. This is amplitude up here. Okay. And then around 1940, our radio wave got a little bit better. So when we moved into FM, FM is you modulate the frequency, okay? This is your frequency. So you can do things with that, or you can do things here. So our cars right now will have AM and FM on it. Yeah.
Where does shortwave fit in that?
Okay, we're coming to that.
Oh, okay.
Okay. You look at this, you have Jack, come up to the table and get one of these.
Okay, thank you.
Then here you have TV. TV is the same thing as radio, except that you've got sound and visual data. Okay? So it's right next to that. Then Jack, if you look there, here comes shortwave. And then your old time A&M radio. So we're up here. You look here, you'll see things that you can do with that sine wave. You can measure the wavelength. You can measure or change the amplitude, the frequency, the speed of it, the phase of it, and polarize it. As we move into digital, this is going to look like this here. It's going to be a square wave rather than a sine wave. Yeah.
I'm gonna ask you something, and I don't even know how to ask it, but,
Okay.
is this kinda like taking fingerprints on different,
I didn't hear that again.
okay, is it would it be kinda like taking fingerprints on a different, wave? Are they all standard to the individual? Like